The question says, given the following reaction, what is the expression for Kc? So Kc is products over reactants. Basically, what's happening at equilibrium is the rate of the forward reaction, the 2SO2 plus the O2 forming the 2SO3, the reaction going in this direction, the forward direction, towards the products, is the same as the rate of the reverse reaction, which is this 2SO3 breaking up into 2SO2 plus O2. So when these rates become equal, we have equilibrium. Note that the concentrations are not equal at equilibrium. What's equal is the rate of the forward reaction and the rate of the reverse reaction. And since this reaction is reversible, this is an elementary reaction. So we can write the rate laws using the stoichiometric coefficients. When we make the two rate laws together and we set them as equal, what we end up with is products over reactants. So the expression for equilibrium, Kc, which will be important in this chapter and the next three chapters, is equal to the concentration of the products, in this case SO3 squared, because it comes from the rate law, so we use the stoichiometric coefficient as the exponent, divided by the concentration of the reactants, in this case SO2, again squared, and then O2 to the 1, and because it's to the 1, we don't write it. So this is the expression for Kc. Again, it's products over reactants, and you can see this derived in the lecture notes. Or from the lecture course, where you have, the rate of this reaction, and you write its rate law, and the rate of this reaction, the reverse reaction, and you write its rate law, and then you set those two rates as equal because that's what's equal at equilibrium, and then you do the math. You find this is your Kc. All right, because don't forget that those rate laws have K's in them, and this is just a new K. All right, next one. It says, if the equilibrium constant for this reaction is 3.7 times 10 to the minus 7, are the products or the reactants favored? Well, let's look at the math here. Products are on top and reactants on the bottom. This number is very small. It's much less than 1 because we have a negative exponent here. So this is a very small number. That means, relatively speaking, we have relatively little product and relatively large amounts of reactants. To get a small number, we need a small number up here and a big number down here. To get a big number, a number greater than 1, you need a big number down here, a big number up here, and relatively small numbers down here. So there, the products would be favored. But in this case, the reactants are favored because this is a small number. That means we have a small number up here and a relatively big number down here, and that gives us a small number or a number less than 1. So in this case, the reactants are what is favored because this is less than 1. Next question, it says, what is the equilibrium constant of the reverse reaction? Well, the reverse reaction would be this is the reactant and these are the products. Said another way, the Kc value would flip. So if you know the Kc of 1, the Kc of the reverse is 1 over the Kc. In this case, it's 1 over 3.70 times 10 to the minus 7. And when you do that math and you take it to three significant figures, you get 2.70 times 10 to the 6th. So you take the reciprocal, because when you do the reverse reaction, basically products become reactants and reactants become products. Said another way, this Kc expression is written upside down, so you can just take the reciprocal of this. That will give you the opposite. All right, the next one says, what is the equilibrium constant for this reaction? In this case, we have 6 SO3. So SO3 was here, now it's here. Yields 6 SO2, all right, and 3 O2. So what did we do with this thing? We reversed and tripled it. So we have the Kc of the reverse and the triple. So in this case, the Kc of the new reaction, okay, is going to be equal to 1 over the Kc of the original reaction. Why? Because we reversed it. Just like we did in the previous case, SO3 is now the reactant instead of the product. But we also tripled it. So we need to take that and we need to cube it. Now, you could simply just cube this number because you just did 1 over the Kc, or you could just do 1 over 3.70 times 10 to the minus 7, and then take all of that and cube it. And when you do that, you get 1.97 times 10 to the 19. So if you triple a reaction, you would cube the Kc. Said another way, this would first be on the bottom because it's a reverse reaction, but it would be to the 6th. This would be to the 6th, and this would be squared. So cubing the Kc accounts for all of that.